So in this question, we have magnesium bromide, or MgBr2, and we're going to take 0.6 grams of the MgBr2 and put it into a volumetric flask that has 100 milliliters of water. And what we want to know is, we want to know the Br minus anions that are going to be in this solution, because when you take MgBr2 and you put it into water and it dissolves, it's going to make a cation, which will be the Mg, and an anion, which will be the Br right here. And so what I'm going to do is make a picture for what's going on in the problem. And so in this picture, I'm going to put my volumetric flask right here. And so here is my volumetric flask. And what I'm going to do is I'm going to take the 0.6 grams of the MgBr2, and I'm going to take that and put it into here. And so we're going to have just a solid of this in here for now. And then what we're going to do is we're going to take the 0.6 and add it to 100 milliliters of this water. And so I'm going to put 100 milliliters down right here. And when we take the 0.6 grams and put it here at the solid, and then we add the water, this is going to go from a solid to an aqueous. So this is now going to be an aqueous solution, which means this is all going to be dissolved in here. And so once it's dissolved, we're going to get the two ions, which are going to be the Mg and the Br. And so that's going to be a reaction that we can write down. And so I'm going to put down that we have MgBr2 here. And when this is dissolved, it breaks at the second capital letter. And the second capital letter is going to be right here. So I'm going to put a line down here. And that's how I'm going to get Mg for the first part. And I'm going to get this Br over here for this next part. Now, to get the charges of it, I'm going to look down here and say I got two of these. That means this right here, this Mg, needs to be a +2. So I'm going to put a 2 plus here, and then to get the charge for this one, there's a 1 right here, and so I'm going to bring that 1 up there, and this will be a minus right here. And this trick will always work for the second capital letter, because if you have a polyatomic ion, which is going to be two different elements that are going to be put together to act like one, those are mostly negative, and so they're always going to appear on this right side. So the line going down here at the second capital letter is going to always work, except for positive polyatomic ions, which are going to be on this left side. And a positive polyatomic ion is going to be something like NH4. So if you see NH4, this trick's not going to work. But for all other polyatomic ions that are negative, this trick will work. And because I don't have any polyatomic ions in here, I don't have to worry about that. But this is what I always do. I always put a line at the second capital letter. And now what I got to do is I got to balance this. And to balance this, I have two BRs here, and I have one BR over here. So I'm going to put a 2 right here to balance this. And so what I'm going to do now is I'm going to find the concentration of the MgBr2 right in here. And so if I know the number of grams, I need to find how many moles that is. And a mole is going to be equal to the amount in grams divided by the molar mass. And the molar mass just comes from the periodic table. So if I have 0.6 grams here, and I divide that by the molar mass, which is 184, I'm going to get 0.00326, and this will be moles of MgBr2. And so if I know the number of moles of this in here, and I'm trying to get the molarity, well, the molarity is just going to be equal to the number of moles divided by the volume, and the volume has to be in liters. And so we need to convert this number here to liters. And so what I'm going to do is I'm going to take the 0.00326 and divide that by the volume in liters. And so we're going to take the 100 divided by 1,000. That's going to be 0.1. And so when I do this calculation out, I'm going to get 0.0326, and that will be the molarity of MgBr2, like that. And so that number here is going to go right here and say we have 0.0326, and that's going to be the molarity of this MgBr2. And I'm going to go from this part here to this part over here, the Br. And so what I'm going to do is I'm going to take this number here and put it over 1. That's going to be what I'm given, and this is going to be the MgBr2 here. And so I'll put that over 1 like that. And then what I'm going to do is I'm going to put the MgBr2 on the bottom, and then I'll put the Br minus up top, and that way this and this will cancel out, and then I'll be left in this Br minus right here. And you can do calculations like this when you have a molarity like this and the volume doesn't change. And so because the volume doesn't change, we have 100 milliliters throughout this entire question, I can use molarity right here instead of using moles. And so what I'm going to do is I'm going to look at the balanced reaction, and I have a 2 right here, so I'm going to put a 2 right here. And I have a 1 right here, so I'm going to put a 1 right here. And so when I do this number here, times 2 divided by 1, I'm going to get 0.065, and that will be the molarity of the Br minus anions in solution. So this number right here, the 0.065, is going to be the answer.